Hello, I'm Jeff Cousineau, a project engineer here at OPW, and I'm in our Advanced Technology Center today, here to show you how to properly inspect and maintain the OPW Epsilon dry disconnect valves. The Epsilon valve set is comprised of an adapter half, which has a fixed end, and a mating coupler half, or hose half, which has a swivel end. The first thing to discuss is safety. Please make sure to wear all proper PPE as designated by local codes or plant specifications. Gloves and eyewear are strongly recommended. Whoever is performing the inspection and maintenance must be familiar with any chemicals that have been run through these valves and be familiarized with the proper procedures, safety procedures for those chemicals. Also, the pipe wrenches for installing and removing these valves can leave burrs on the back edges. Please be aware of any sharp edges or burrs that can cut. Some tools OPW recommends you have before your disassembly: a soft seal pick to remove the transfer seal, an Allen wrench to remove the flange screws and the ball plug screw, a socket and a torque wrench for the handle nut and the stem bearing, and an open-ended wrench to manipulate your stem, a container to catch the ball bearings as they fall out. OPW recommends using blue Loctite and Krytox grease on the ball seals. And lastly, an ohm meter to check the continuity through the unit as it's done. We recommend using a vise with soft jaws to hold your unit while you work in place. Record keeping is an important aspect of maintenance that is often overlooked. It is important to know the service record of the valve to keep it properly maintained. On the side of the valve, you'll see laser engraving with various information about the fitting, including the OPW part number for the specific configuration, as well as the date of manufacture and the unique serial number. We recommend documenting the performed maintenance and inspection and tying it to the serial number for future reference. The first thing that we'll do is we'll do a general inspection of the adapter half. Common wear items include the handle, which can bend over time, and the yellow covers can be worn off. The handle nut, which can loosen over time after repeated rebuilds. OPW uses a blue Loctite to keep this in place, but over time the Loctite can be worn and needs to be replaced. The cap should be connected to the adapter with a lanyard. It should be unbroken and clean underneath. The hub pin is something else to inspect. Make sure the hub pin is coming out completely from the hub. Sometimes it can get clogged up with dirt and debris over time. And most importantly, the face of the adapter. The lugs of the adapter, which mate with the coupler, should be free of burrs and nicks. The diameter should be inspected so that it's completely round. If the unit is dropped, flat spots can occur on the edge of the diameter and can cause leaking. And the face should be free of scratches and marring, including the ball and the ball seal. This seal is referred to as the transfer seal, or the face seal. It is the seal that is responsible for preventing leaking when the units are connected and open. If you see dripping while the units are connected, then this is the seal that will likely need to be replaced. The transfer seal is the seal that is most exposed to the environment. Therefore, it is most likely to be worn down most quickly and be replaced most quickly. The good thing is there's no disassembly required to replace the transfer seal. You can use a soft seal pick to remove the transfer seal at any point. Due to how tightly the transfer seal fits into the groove, a transfer seal that has been removed has a very little chance of being an effective seal again. So OPW recommends throwing away the seals once they've been removed. The transfer seal is not symmetrical. It does have a specific orientation it must be installed. There is a flat side that has a lip that must go down into the body. If an attempt is made to install the seal upside down, it will easily fall out. When reinstalling a new transfer seal, OPW recommends using a clean mating coupler as a method to evenly press the seal into the adapter. This firmly seats the transfer seal in the adapter body groove. Now to disassemble the unit and replace the other seals and wear items. First, we remove the handle nut. And we remove the handle. And then we can carefully remove the hub assembly, making sure not to drop the detent ball. One thing to inspect is on the body between the two detent areas. Make sure there's no grooves Next, we will remove the stem bearing. And we now can remove the stem. Sometimes the stem seal stays attached to the stem. Sometimes it stays in the body and you have to reach down and pull it out. Next, we're going to flip over the adapter to the back side and we're going to remove the 4 flange screws. We carefully lift the adapter off. Now we have access to the wave spring, the wave spring washer, and the ball retainer. We can now remove the flange seal, and now we can remove the ball. Be careful not to drop the conductivity spring. And the last soft item is the ball seal, which is down in the body. We've now done a complete disassembly of the adapter body. One last thing to look for inspection is the interlock pin. Turn the body upside down and you can drop out the pin and the spring. Make sure the pin is straight and free of damage. We begin the rebuild by reinserting the pin, the spring, and the pin retainer. Next, we will put the stem seal onto the stem, and we'll put the stem into the body with the flat side facing the pin. Next, we will put a drop of blue Loctite on the stem bearing, and we will use the stem bearing to thread down and evenly push the stem seal into the body. Be sure to tighten down the stem bearing to the specified torque value. We will insert the ball seal. No specific orientation is needed with this. OPW recommends putting a very thin layer of Krytox grease on the ball seal. Next, place the conductivity spring in the ball slot so the peak is in the middle, and slide the ball into the body so that the concave portion is facing forward. Next, we put a little bit of Krytox grease on the edge of the inside edge of the ball retainer and install the ball retainer with the flat sides on the top and bottom of the ball. Next, we install the flange seal. Now we place the washer on the back of the ball retainer and the wave spring on top of the washer. Now we can place the end connection in any orientation. We apply Loctite to the flange screws and hand tighten them evenly. Tighten the flange screws evenly to compress the wave spring. Torque down the flange screws to the specified torque value. Now we can turn our adapter so we can rebuild this hub components. First, place the detent ball and the detent closest to the front of the adapter. Next, install the hub assembly with the pin in the back. Now replace the handle with the bend going upwards. Here we would add a drop of Loctite onto the threads and replace the handle nut. Torque the nut down to the specified torque value. And we've now completed our rebuild of the Epsilon adapter. Now we move on to the inspection and maintenance of the coupler half. All of the same wear items exist in the coupler as did in the adapter, with the addition of a couple more. The handle nut, the hub pin, the dust cap, but also in the coupler we have the ball plug screw. Make sure that's tight and secure. And the hub latch. Check that for burrs and damage and make sure it moves properly. First, we're going to remove the bumper. Next, we're going to remove the ball plug screw. Now we can slowly turn the end connection and the ball bearings will fall out. Make sure to capture the ball bearings in a container or a soft cloth. Once all the balls are out, you can remove the end connection. Now we can remove the swivel seal and also the stem bearing. The stem bearing can be a little tight, so use your time to work around the edges to get it out. Next, we will put the unit in a vise. Next, we will take the handle nut off. Remove the handle and the hub, being careful not to drop the detent ball. Next, remove the stem bearing. And remove the stem. Now we will remove the 4 flange screws. Now remove the flange. Remove the ball seal from the back of the flange. Carefully remove the ball, catching the conductivity spring as it falls out. Now we can remove the flange seal, the ball retainer, and wave spring washer, as well as the wave spring. We can also now pull out the interlock pin and inspect it. Look at the interlock pin and make sure all the teeth are intact and the pin is still straight. And that concludes our disassembly of the coupler. Now we're going to rebuild the Epsilon coupler. We're going to start with the stem area, put the stem seal onto the stem, and insert into the body with the teeth facing the interlock pin. Put a drop of Loctite on the stem bearing and use the stem bearing to tighten down over the stem so the stem seal goes in evenly. Tighten down the stem bearing to the proper torque value. Now to insert the interlock pin. Insert the interlock pin into the interlock hole with the teeth facing the stem. Rotate the stem in a clockwise motion as the pin clicks over the teeth. About 5 clicks and it will stop clicking. Now you can turn back counterclockwise and draw the pin back into the body. Go until the stem is pointing forward and backward where we started. If done correctly, going from open and close will move the pin in and out of the body. Leave the pin and stem in the backwards position. Next, we put the detent ball in the detent area that's closest to the front face. When installing the hub, make sure the hub pin is in the rear and you pull the latch back so that it goes over top of the body. Install the handle. Put a drop of Loctite on the handle nut and thread that down onto the hub assembly. Next, we turn the coupler so it is facing up. First, we drop in the wave spring. Next, the wave spring washer with the lip facing down. Next, we put a thin film of Krytox grease on the ball retainer and drop that so that the concave section is facing up. Reinstall the conductivity spring into the top ball slot and reinsert the ball with the rounded convex section facing forward. Next, we install the flange seal. Put a thin film of Krytox grease on the ball seal and set it onto the ball. Now we can reinstall the flange seal with the flat section facing up. Hand tighten the flange screws. Now wrench tighten them down evenly. Use the torque wrench to apply the proper torque value. Inspect the ball bearings to make sure there's no corrosion or chipped bearings. First, install the new swivel seal into the bottom of the body. Next, install the sleeve bearing. Press it in so that it is flat against the body. Next, inspect your adapter swivel area for scratches or marring and install it into the body. Take one of your ball bearings, drop it into the ball race, and press firmly and twist until the ball drops into the raceway. Continue to do this with each ball bearing. After the final ball is added, add a drop of Loctite to your ball plug screw. Tighten it down. And torque it to the proper value. Next, we can reinstall the bumper with the flat section at the top. Start at the bottom, work your way around. Now we've rebuilt our adapter and our coupler. The final thing to do is important if you work in an area with flammable chemicals, and that's to check the continuity through the valve. Get an ohm meter and touch the ball and the stem to ensure you have less than 10 ohms of resistance on both the adapter and the coupler to ensure we have continuity and cannot create a spark. If you have any further questions regarding different sizes or different configurations, feel free to reach out to your OPW distributor and we'll be more than happy to answer those questions for you. Thanks for joining me today. Have a good day.